Good afternoon everyone. Today I shall talk a little bit about ROS. I hope that all of you will be having Linux and ROS installed in your computers and laptops. The stuff I'm going to present is based on book Learning ROS for Robotics Programming, second edition for ROS Indigo. I hope you all will enjoy the session. My name is Dr. Abdul Mannan and I shall be talking about first ROS architecture. These are the contents of my presentation. Today I shall only present chapter number 2, and from this chapter you will learn how to make packages, nodes, messages, services, launch files, and how to write dynamic configuration files. We shall all do this on ROS, but before going in direct hardcore practicing, I shall describe the overview of all these things, explaining how these things work for ROS, and then I shall go in a little bit more detail, and after having that talk, I shall explain how to do that in ROS. This is going to be a long session for about 3 to 4 hours, but I learned this stuff in about 1 month, so I'm going to present it in a very short time. So please have patience with me. Thank you. Okay. In this chapter, what is the objective? In this chapter, we shall learn how ROS is organized and what role each particular folder has. So let's look into that. This is the overall architecture of ROS. It is divided into 3 subsections or levels. The first level is the file system level, then the second one is computation graph level, and the third one is community level. The first level is the file system. In this level, a group of concepts are used to explain how ROS is internally formed, the folder structure, and the minimum number of files that it needs to work. So these things are explained in file system level. The second level is the computation graph level, where the communication between processes and systems happen. In this section, we will see all the concepts and the systems that ROS has to set up systems, handle all the processes, communicate with more than single computer, and so on. The third level is the community level, where there are certain tools and concepts to share knowledge, algorithms, and code from the developer. This level is important because ROS can grow very quickly and with great support from the community. Let's talk about ROS file system level. And when you start working on ROS or develop some projects, you will see that although this concept can sound strange in the beginning, but you will become familiar with it after some time. Just like many other operating systems, ROS program is divided into folders, and these folders have files that describe their functionalities. Here we can see different files. Let's discuss all of them one by one. First of all, you will see the file system level, in which there are meta packages, and under meta packages there are some packages, and in the packages inside, which is the standalone application for some tasks, there are package manifests, messages, services, codes, others, so many things. So this is a typical example of some package in which you see the CMake list, and then you see launch file, messages, SRs, sources, services, these are, and includes. So there are a lot of things in it. We shall in this session we shall make such kind of packages, and we shall see how these things work. But before going in any further detail, let me introduce the basic terminologies. Packages formulate the atomic level of ROS. A package has the minimum structure and content to create a program within ROS. It may have ROS runtime processes, which is called nodes, configuration files, and so on. For example, if you develop a package, say for example to do some task based on your project, you can compile it and share it with others using putting everything under package. Package manifest provides information about packages, licenses, dependencies, compilation flags, and so on. A package manifest is managed with a file called package XML. Meta packages. When you want to aggregate several packages in a group, you will use meta packages. In ROS, Furete, which was the previous version of ROS, stacks were used for ordering packages, but now the meta packages are enough. To maintain the simplicity of ROS, the stacks were removed, and now meta packages make up this function. In ROS, there exist a lot of these meta packages. One of them is navigation stack. And then we have meta package manifest. Meta package manifest, which is called package.xml, are similar to a normal package but with an export tag in XML. It also has certain restrictions in its structure. We shall discuss about them later. Then we go, here come the messages or message types. A message is the information that a process sends to other processes. ROS has a lot of standard type of messages. Message description are stored in my package underscore message my message type .msg. So its extension is .msg. And then here comes the service types. Service descriptions stored in my package underscore slv or my service type .slv define the request and response data structure for services provided by each processes in ROS. We shall have a detailed discussion about these things, so just hold on and have these things in your mind. The key points are packages, messages, services. So the package manifest and meta packages will come to consideration later. Where these things lie on? So this is a term which we call the workspace and its folder in ROS. We have discussed packages, messages, services, and how these things interact with each other in formulating a ROS app. Now let's see how these things are arranged in different folders. In ROS, a folder in which you organize all these things is called a workspace. Basically, the workspace is a folder where we have packages, edit the source files or compile packages. It is useful when you want to compile various packages at the same time and is a good place to have all your developments localized. Here is a typical list of files which are part of these folders. You can see the build, the develop and the src. And in build you have catkin or generated, makefile and so on. The workspace and its folder in ROS. Let's talk about these sources and build space and development space, which we have just seen. The build space. In the build folder, CMake and catkin keep the cache information, configuration, and other intermediate files for our packages and projects. The development space, the develop folder is used to keep the compiled programs. This is used to test the programs without the installation step. Once the programs are tested, you can install or export the package to share with other developers. The source space, which is the SRC. In the source space, this SRC folder, you put your packages, projects, clone packages, and so on. One of the most important files in this space is cmakelist.txt. The SRC folder has this file because it is invoked by CMake when you configure the packages in the workspace. This file is created with the catkin init workspace command. The workspace command. Okay, CMake package build and make is used to build the package. Now let's suppose that you have downloaded some package of ROS from the internet and you want to use it. How can you use it? It's simple. Just compile that package and ROS will generate its executable file to be used. There are two methods for that. Either you can specifically build that particular package, or you can simply send a command to build all packages. So for example, if you just want to build your own package, cmake package to build, you send this command in bash, or you go to the workspace and just write cat make, it will build all your packages. Definitely it will take some time because it will compile all packages and it will be quicker, but it is very convenient to remember. So now let's move on to the packages. We shall have a detailed discussion. A typical structure of files and folders include message, scripts, SR services, cmake list, and package.xml. These are typical files and folders in the package. Usually when we talk about packages, what we actually mean is a typical structure of files and folders organized in a particular way. This structure has folder for each specific task, such as highlighted here. Let's discuss about all these things and their functionalities one by one. Include _package_name. This directory includes the headers of the libraries that you would need. And message. If you develop non-standard messages, put them here. Scripts. These are executable scripts that can be in Bash, Python, or any other scripting languages. So all your C++ or Python languages files will be here in scripts. src. Okay, this is where the source files of your programs are presented. You can create a folder for nodes and nodelets or organize it as you want. So in the src you put your source files, and I'm sorry it is not here, but it is used. Srv, this represents the service types. What are the services? We shall talk about these things later. Cmake list, this is the cmake build file which we had talked. This is very important file, we shall talk about it. And package.xml, this is the package manifest. So this is the typical structure of a package. And these are some important commands before starting. As discussed before, that you want to develop some ad, if you want to develop some app, or you have downloaded some from the internet, and you want to modify it. To do that, there are some tools available in ROS. These tools are ROSpack. This command is used to get information or find packages in the system. So if you want to find out some package, you can use it. Cat can create package. This command is used when you want to create a new package. And cat can make. This command is used to compile a workspace. So this command will be used very frequently for every package, and for the cat can create package we shall use this file. In this session we shall use this very extensively. Note that this command installs the system dependencies of a package. And the rqt_dep, this is used to keep the packages dependencies as a graph. You want to see the package dependencies as a graph, you will find a plugin called package graph in rqt. Select the package and see the dependencies. We shall discuss about it. Purpose of mentioning all these commands is to give your brain an idea that there are tools available. You may not memorize it right now, but just keep in mind that there are tools that are available, and when we will need it, we will find it. Okay, these are some basics before going in a hardcore practicing, and this will be very important. To move between packages and folders, normally in Linux we have the command cd But once you are in the workspace and you want to move between the one package from one package to another package, there is a command which we call ROS-CD. It is a very useful command. You don't need to go back to your home directory and then come forward to other directory, and you don't need to write the complete address. Just write ROS-CD and write the package. It will take you there. ROS-ED, it is used to edit a file. If you want to edit some file using which has some built-in functionalities for ROS, instead of opening it by right-clicking and editing in some particular compiler or some particular editor, just write ROS-ED and it will open the editor. If you want to copy a file from a package, the ROS-CP command gives you many advantages. ROS-D, it lists the directories of a package. So instead of understanding the Linux, it is very useful. ROS-LS is just like ls command of Linux, and it is useful for the ROS. Package.xml file, the must be in a package and used to specify information about the package. Don't worry about it, we shall see a lot of things about it. And the package XML file must be in a package and it is used to specify information about the package. If you find this file inside a folder, probably this folder is a package or a meta package. If you open the package.xml file, you will see information about the name of the package, dependencies, and so on. All of this is to make the installation and distribution of these packages easy. Two typical tags that are used in the package.xml file are build depend and run depend. The build depend tag shows what packages must be installed before installing the current package. This is because the new package might use a functionality of another package. The run depend tag shows the package that are necessary to run the code of the package. The following screenshot is an example. You can see that whenever you make a package, you need to add changes on it, like build depend, run depend. This is one of the very important part. Let's talk about meta packages. As we have shown earlier, meta packages are special packages with only one file inside. This file is package.xml. Now we have one package.xml file in a package and we have one package.xml file in meta packages. This package does not have other files such as codes, includes, and so on. Meta packages are used to refer other packages that are normally good following a feature-like functionality. For example, navigation, stack, ROS tutorials, ROS CPP tutorials, and so on. You can see that these are stacks in meta packages. You can see the content from the package.xml file in the ROS tutorial meta packages. You can see the export tag here. Okay. And run depend tag here. You see. These are necessary tags in the package manifest, which is shown in the following screenshot. So in short, it organizes whatever you need for the package under consideration and wherever it needs to run. So in the meta packages, in the package.xml file, you arrange run depend. It depends on other package.xml files. Let's talk about some messages. ROS uses a simplified message description language to describe the data values that host nodes publish. With this description, ROS can generate the right source code for these types of messages in several programming languages, including C++ and Python. A special type in ROS is the header type. This is used to add the time, frame, and so on. This permits you to have the messages unnumbered, to see who is sending the message, and to have more functions that are transparent for the users and that ROS is handling. It is really an important message type. By this message type, it is possible to record a timestamp. Okay, These are the different messages type. You can see bool, int, and other primitive specialization. There are C++ and the Python. They are all standard and used in ROS. There is a special message type which we call the header type. It contains the following It contains the following things. It is which is unsigned in sequence, timestamp, and frame ID. Of course, you can change it, but what I want to highlight is these two things. It is really an important message type. By this message type, it is possible to decode the timestamp and frame of what is happening with the robot, as we will see in the upcoming chapters. This is very important message type. By this message, we can literally see what is going on with the robot at what time. Services. ROS uses a simplified service description language to describe ROS service types. This builds directly upon the ROS message format to enable request-response communication between nodes. Service descriptions are stored in SRV files in the SRV subdirectory of a package. To call a service, you need to use the package name along with the service name. We shall practice it in the ROS later. For example, you will refer to the sample package 1 SRV sample.srv file as sample package 1./sample1. There are tools that exist to perform functions with services. The ROS service tool prints, there are many tools about that. The ROS SRV tool prints of the service description and packages that contain that SRV file, and find the source file that you use that choose a service type. If you want to create a service, ROS can help you with service generator. These tools generate code from an initial specification of the service. You only need to add gen srv line to your CMake list .txt. Any service you create, you must enter in CMake list .txt. Now you might be thinking, what the hell is going on here? It is very difficult concepts, so a new concept for the beginners. You might be thinking that what the hell is going on? I thought that I shall learn ROS like any other software to click here and there and doing something using mouse or keyboards, but here I'm learning folders and other stuff. Let's remind that ROS is not an operating system, but at the same time it is a platform in which you can build your apps for robots. Like mobile phones have Android, computers have Windows and Linux. In the same way, ROS runs under Linux and helps you in making different apps for robots. The information we are just studying is more about folder type and not the structure type. Don't you think that if we might have studied how typical package works in ROS would be a better idea? You know what? You are right. This is term for what? This is term for what? There is a term for that. There is a term which we call computation graph level description. Let's say you have an app. How would you see what is going on? Yes. Folders and descriptions provided above is folders and descriptions are provided, but how would you see what is going on? This is the question. ROS provides an amazing visual tool for that. It is so fascinating that it makes programmers feel very easy to find out where something is going wrong. So from now we shall see about these things. In this chapter we shall learn the same thing which we learned previously, but a bit more detailed. Don't worry, in this session we shall learn how to use these things as well. So now this is ROS computation graph level. ROS creates a network where all the processes are connected. Any node in the system can access this network, interact with other nodes, see this information. This is the node. see the information that they are sending and transmitting data to network. This is particularly useful for debugging really big programs. Here you see, have any of you seen LabVIEW? In LabVIEW, people graphically connect different items by which they see which part is doing what. For the similar purposes, ROS builds such graph level tree. You can actually see who is doing what and can further explore to modify and change the package for your own purposes. The basic concept in this level are nodes, the master and the parameter server, messages, services, topics and bags. So this I'm trying to show you the computation graph level here. Look at this picture very carefully and just take as many snapshots in your brain as you can, because we shall be discussing these things extensively. We have nodes, master, program, parameter server, and messages, topics, services, bags. We shall practice today nodes, topics, services, bags, messages. So in this graph you can see the nodes, the topics, which node is subscribed to, and so on. So basically this is node, it is sending a message, and this node is subscribed to this. So that's how they are doing the stuff. This is also sending a message, and this one is subscribed to this. So it is receiving. This one has not subscribed to any of the node previously, but it is sending the messages. So this is the structure which you can see in ROS. This is not handmade. You will type in the command and you will see this structure in ROS. This is very convenient in debugging a program. Now we shall talk about in detail about nodes and nodelets. Okay, the nodes are executables that can communicate with other processes using topics, services, or the parameter servers. Using nodes, ROS provides us with fault-tolerant programs and separates the code and functionalities, making the system simpler. But here is another thing. ROS has another type of node called nodelets. These special nodes are designed to run multiple nodes in a single process, with each nodelet being thread-like process. This way, we avoid using the ROS network among them, but permit communication with other nodes. So, for example, if some node is, you want to build a big node, instead of seeing a very complicated graph, inside it you can create some nodelet, and with nodelet you will see overall this one node, but there are some inside, there are some many other nodelets. A node must have a unique name in the system. This name is used to permit the node to communicate with other nodes using its name without ambiguity. A node can be written using different libraries such as ROS-CPP, ROS-Python, and many others. So you should remember that for the same, if you are writing some complicated program which does not require so many computations, but it's an algorithm, you may write that program in Python, but for the program you need a lot of computations and you want to make it real fast, you can write it in C++. So at the same time you can use C++ and Python. So you will have to choose between these two languages where you should use C++ and where you should see Python. Remember that Python is very good for writing algorithms but not good for computations, where the heavy computations are involved, such as dynamics, such as visual information extraction and some other things. C++ is good for those tasks. But if you have just some algorithm like get this information and do that, and take this information and do that, the Python is a very fast way to do that. It's really fast. And this is just some tools about nodes. Just have a look on it. We shall discuss about it later. ROS node info, I'm just mentioning it for the sake of completeness. So just have a look. ROS node info, node prints info about a node, kill, kills, lists all the active nodes, machine hostname, lists the nodes running on a particular machine or lists machines, and ROS node ping node, test the connectivity and clean up. This is not clean up, this is clean up. So it provides registration information from the unreachable nodes. So these are the tools. I don't want you to remember it, I don't expect you to remember it, but just have a look. Now we shall move on towards topics. Remember in a package, nodes, topics, services, messages. We are going to discuss about topics. Topics are named buses over which nodes exchange messages or transmit data. Topics have anonymous publish subscribe semantics, which decouple the production of information from its consumption. In general, nodes are not aware of who they are communicating with. Instead, nodes that are interested in data subscribe to the relevant topic. Nodes that generate data publish to these relevant topics. There can be multiple publishers and subscribers to our topic. If me and Hashim both needs one thing, we can both subscribe to that topic. Topics are intended for unidirectional streaming communication. It is a fast way. Nodes that need to perform remote procedures, calls, and that will receive a response to a request should use services. It should be kept in mind that topics are not two-way communications. Topics are one-way communications. Nodes that need to perform remote procedures, calls like I want to ask something from Hashim, give me this. So for this, topics cannot be used. For this, in ROS, there is another thing which we call services. We shall talk about this. Okay. A topic can have various subscribers and can also have various publishers, but you can take care about publishing the same topic with different nodes because it can create conflicts. Each topic is strongly typed by the ROS message type used to publish it, and nodes can only receive messages from a matching type. A node can subscribe to a topic only if it has the same message type. So these are all the topics. It can transmit topics in ROS can be transmitted using TCP/IP and UDP. These are the standard protocol. UDP-based transport is known as UDP ROS, and it is a low latency, lossy transport system. It is best suited to tasks such as steady operations. These are some standard tools for topics. Just have a look on it. And bandwidth, echo, find message, hertz, info, list up. So let's talk about some services. When you need to communicate, as it is already mentioned, when you need to communicate with nodes and receive a reply, you cannot do it with topics. You need to do it with services. A reply is done by a service which is defined by a pair of messages, one for the request and one for the reply. Providing host node offers a service under a string name and client calls. So these are the services which are okay. Let me discuss about service types. Like topics, service has an associate service type, that is package resource name of the .svb file. Services are developed by the programmers, and the standard services do not exist for nodes. ROS has many commands for that, and we shall make this, and you will have better intuition about that. These are some tools about ROS services. Just have a look on it. Let's move on towards messages. Nodes communicate with each other by publishing messages to a topic. A message is simple data structure comprising type field, standard and primitive types, integer, floating points, booleans, etc. or strings are supported as arrays of primitive types. Messages can include arbitrarily nested structures and arrays as well, like C structs. Let's talk about little message types. Message types use standard ROS naming conventions, the name of the package, name of the message file. For example, standard message string.msg has the message type standard message string.in. I have tried to. These are some standard message types, and one of them is a header message, which we have already discussed. It contains the timestamp and some common metadata file. Okay, which we shall discuss about it. Header messages I have already discussed. So these are some tools for the messages. Just have a quick look on it. And then I'm going to just mention it for the sake of completeness. But in today's session we shall skip it. Maybe we skip it. A bad file is created by the ROS, which is in the .bag format to save all the information of the messages, topics, services, and others. So it is used for offline experimentation. You just record the data, you just record everything from the real hardware and save it in a bag file, and then you want to use it, just use the bag files. These are some tools for that. Now, ROS master. I want to mention and describe all those things. I hope that this will go in your mind. These are really basic things, and at this time maybe you will be thinking this is a little boring, but that's what the ROS is. A ROS master provides naming and registration services to the rest of the nodes in the ROS system. It tracks publishers and subscribers to topics as well as services. The role of the ROS master is to enable individual ROS nodes to locate one another. Once these nodes have located each other, they communicate with each other in a peer-to-peer fashion. You can see is here. This is the ROS master. The sensor advertises the data, and then ROS master knows that it is here. And sensor has subscribed to a data, which is another node, and it is saving it. And then the request lot this is another node which subscribes to the master, and from master it knows that okay, master knows that there is another node which we call request lot. Now master connects both of these. The sensor publishes data and request subscribes to data. So that's how these things communicate. Without master, they cannot communicate. Okay, parameter service is a shared multivariable dictionary that is accessible by a network. And nodes use this server to store and retrieve parameters at runtime. Parameter server uses XML RPC data types for parameter values, which include the following: 32-bit integer, boolean strings, double ISO 8601 dates, list, and other things. These are some tools for ROS parameter server. Okay, now from up to this much level, it was the basic. We discussed about messages, nodes, services, and packages, everything. Now I want to show you, if you have some problem, there is a big community out there. They are really good. If you make an account and you have some question, just write with the appropriate heading names. You will find a lot of community eager to help you out. This is really good community, and I think that they are paying some people to do that, but they are still call themselves volunteers. But still, it is a good thing. You can find similar to Linux distribution, collection of meta packages that you can install is there in distributions, repositories, and the ROS wiki is the best thing. Bloggers, answers, a lot of things in there. And most of the material about ROS is not in books, it is in ROS wiki. The book we are studying is outdated. You will see many problems in it. But when you go online in community, you will see these things. So I know this was a very boring session of 30 minutes, 30 to 40 minutes, but now we shall practice some ROS. So should I go on or should we take some break?
We should take a break.
Okay, let's pause.
One.
So in today's section we shall learn how to navigate some basics, and we shall create our own workspace, create and build a package, and play with ROS node, interact with topics, and then we shall use services. These are already in ROS tutorials, but then we shall create a node, we shall build a node, and then we shall use services and messages file, and then we shall also use a launch file. So let's just go through it. I was expecting that you guys will be having the laptops and we shall practice side by side, but let's just go for it. Okay, so do you want to, this will be good. Okay, so these are some commands: ROS-LS, ROS-PACK, ROS-TAP, ROS-CD. We shall talk about it, but let's just first create our own workspace. So before going to do that, this is a bash file. This is a bash, which is also called a terminal in Linux. And before going to the CD source, it's called opt_ROS. If you are using Kinetic, you have to your distribution, and in this is Kinetic setup.bash. So if this is fine, it will give you nothing. If there is some problem, it will show you. So it means the source of ROS is here. OPT, you can also see that here. Is it working good?
CD is one of the
directory. Move to one directory to other directory.
CD is
yeah.
CD simple ROS CD.
Yeah, in Linux, if you have to move to some other directory, you type in CD directory, you move in that. In ROS CD, if you are in the ROS workspace, to move between any two packages, you don't need to write the complete code to go to that directory from home to blah blah blah. If you're in workspace, just write ROS CD and package name. That's it.
उसके लिए ROS code पहले run करना जरूरी है?
No. ROS-LS, ROS-PACK, ROS-TAC, ROS-CD. Just write the package name. ROS-TAC, package name. ROS-PACK, find package name. ROS-PACK, ROS-LS, list. You want to see what is inside some package? Just ROS-LS package name. So do things.
So this command is actually switching from terminal to ROS terminal.
Which one?
Yeah, this we have written source.
Yeah. So if everything is fine, it will give you nothing. So it's just the the user-friendly test that okay, everything is okay. Now let's just make a directory. It can also be used for what?
I think the ROS commands can now be understood by this terminal.
Yeah, this is also a good thing. Yeah, ROS commands can be understood by the terminal now. And let's write some directory. Make directory -p underscore. Okay. In my computer, this directory is already there. But in your computer, I don't know if it is there or not.
Make directory minus
P.
Yeah.
You didn't put P.
Okay. Make directory -p. Yeah. Yes. So it is here. Catkin. It is here. Okay. So okay, if you go further, is everybody okay now?
Yes.
Shiraz? Okay. Now I want to initiate the workspace. Okay. So first of all, let's go into the source file. We just created. And then I shall run this command, catkin initiate workspace. Catkin init workspace. So in my case, this file is already there. Go into the section with catkin in it. Is it working? CD. Okay. So is everybody ready now? Okay, So we initiated the workspace. Now remember that we have to compile that. We have gone through up to this much, and now we have to build the workspace. So first move to the workspace directory by typing in this. So now you are in the workspace directory. So you have to include tilde. And backslash also.
Then we can
Backslash. No.
CD down.
Okay. Okay. But if you anywhere you just type this command, you will go to the catkin workspace. So you need to add the backslash. That's right. So in here you will type in catkin underscore make, and then it will build everything for you. But because I have already chapter 2 tutorials, so I have been having a lot of things in it, but for you it will be simple then. So type in command catkin underscore make. Once we have created a workspace folder, there are no packages inside, only cmakelist.txt. The next step is building the workspace. To do this, we shall use the following command. We have already made the catkin underscore make, but to finish the configuration, you need to enter this. Whenever you start new terminal, and the backslash shouldn't be here. No. And this is important, and this step is only to reload the setup.bash file. You will obtain the same result if you close and open a new shell. So if you don't enter it, the ROS will not update your stuff in that, and when you enter it, it will say I'm not seeing the directory. So just enter source devel underscore setup.bash whenever there is a problem. The first thing you should enter, if there is some problem, enter source devel backslash setup.bash. I think this is forward slash, right? Is this forward slash or backslash? Forward slash. Forward slash. So the configuration is finished. Now let's create a package. So first go to cd, run this command. Okay, you can also clear your whole bash file by typing clear. So it will take you to the first line again. cd catkin, it will take you there, and then the command to create the package is catkin create p. I shall tell you in the catkin create package, create the package, then this comes the package name, chapter 2 tutorials, and then it comes the dependencies. one dependency is standard messages and the other one is ROS CPP. So let's enter it. So in my case the file is already there, so there is a saying that it is already there, so you don't need to create it, but in your case it will be different. Okay, so now we have to build that package. So whenever you have to build that package, you need to go to the root directory of the your workspace. So like this, cd catkin underscore workspace, and then you have to run this command catkin underscore make. First go back, because now we have built a package. You want to build that package, so go back to your root directory and then because I have too many things already in my that tutorial, so you have to run these two commands. Okay, and then okay, now we also need to bash
सेटअप भी होगा शायद, ये सोर्स लिखना होगा, गलती से लिखना होगा।
This command is not needed, so don't need to write it. This command is not here. In my updated presentation, this and this was updated. This is not required. So let's so far so good. Let's clear it. Now we shall play a little bit with the ROS with the ROS node. So let me refresh it. What is ROS node? Nodes and nodelet section, there is something like that. Nodes are executable programs, and these executables are in the develop space. If you go in your home directory where you have your catkin, and there is a develop space. Okay, these are executable in your in develop space. To practice and learn about these nodes, we are going to use a typical package called TurtleSim. If you have installed the desktop installation, you will have the TurtleSim package pre-installed. If not, install it with the command. I assume that you guys have already installed TurtleSim package. So
They are stored or
yeah.
they are really stored or not?
So I assume that you have installed the desktop version. So now we shall write commands about TurtleSim tutorial. So before doing anything, first of all, before running any node, first you need to run the ROS code. it will show you something like that. So type in ROS code. It is before running any node you need to run it. This is some like master type something ROS code. So, and see that you cannot enter any other thing because it has started the node. In this terminal you cannot write anything here. So to run the node, what you need to do is to open a new terminal, which is Ctrl plus Shift plus T. So in that you write ROS run. This is the node. PURTLESIM, package name. PURTLESIM. So this one is package and this one is node. In the desktop version, this tutorial is already there, so just enter it.
How to open in tab?
Huh?
How you open two windows in that tab?
Control Shift plus T.
Control Shift T.
T.
Remember, this one is package name and this one is node name. So the node is here. You have to run this command.
Are we looking at writing this?
Okay. Now let's again open another terminal. Control plus Shift plus T. So let's see what information do we have about the running node. ROS node info. See. Okay, you must specify at least one node name. ROS node info. We have just opened turtle. You don't need to write the node, you just need the package name TURTLESA. So you will see commands like there are things which were available, lots of ping, lots of list, info, machine, kill, clean up. These are all things here. New terminal, Control plus Shift plus T, new tab. This is more convenient. So you can see these options for that node. Let's move on and do something interesting. And yeah, you will also see the different publication and subscription and different services. So
Control plus Shift plus
T. If you want to see some information about the ROS topic, so just type in ROS topic bandwidth and H. You will see the information about the ROS topic. Okay. There are many commands like ROS topic, bandwidth, echo, find. There's so many things. You can explore it in your free time. So let's interact with the topic. So what is the topic? Before I would like to describe what is the topic. Okay, let me refresh it. Topics are named processes over which nodes exchange messages, and topics have anonymous published subscribes or semantics which decouples the production of information from its consumption. So basically topics are named processes over which nodes exchange messages or they exchange information. So to interact with the topic we have this, let's run a topic ROS run turtle sim. This is also we are also going to run a turtle sim. This is another node, so let's just run it. Here we're going to run this, we're going to run this. So now reading from keyboard. So where is my, here. Now to, this is one node and this is another node. So one node is subscribing to that. So if we keep our focus on this window, we shall see that how this node will interact with it. See, you can move your cursor. Congratulations, we have just used your first program using ROS. Is it good? Is it nice? Let's play a little bit. Okay. So the node is publishing a topic that the second node can subscribe to. Obtain the available list of topic, this is ROS topic list, and then run to see the message level. So you can see the ROS topic echo, turtle 1, CMD value. Let's see what it does. The two nodes are running, one is publishing something, another one is subscribing it to. So Control plus Shift plus T, another tab. So we have these topics: ROS out and ROS out and AGG aggregate, I think. Turtle 1 CMD, Turtle 1 color sensor, and Turtle 1 post. So these are the topics. So let's run the ROS topic echo Turtle 1. What is the topic inside it? So ROS topic echo b underscore b. We are going to see what is inside this topic. So you can, I have to take this out, and if you put your focus on this, where we run the teleop key, and let me show you this turtle, focus on this, and you move your key with it, you will see that this will print out the XYZ values and angular values. So you see, this command is publishing velocity and the CMD value. I don't know what it is. I think it's the XYZ values of it and the angular values of this. move on towards. Is everybody okay? Okay. Now let's move towards services. Services are another way through which nodes can communicate with each other. Services allow nodes to send and request and receive a message. The tool that we are going to use to interact with the service is called the ROS service. The accepted parameters for this command are as follows. Like this: ROS, ask, call, find, list, type, and right. So we are going to use ROS service list. We have already run ROS code, so we shall just run ROS service list. Just Control plus Shift plus T, another tab, and type ROS. So you can see all the services available for that. So there are many services like clear, reset, everything. So for example, if you want to see any services like ROS service type clear, you will see something like just type ROS service type underscore black line clear.
space देना type है type to space देना था.
So sender service is empty, but you will see something amazing. Not yet. So this service is empty. Okay. So if to invoke a service, you will use ROS service call. If you want to invoke the clear service, use the following command. So we have these many commands. We have used this one. Now we want to use. Okay, to call that service, we need to use with the call. Let's say that ROS service call clear. Right now we just type ROS service type clear. So let's now invoke it. Now we are calling this service. First we checked in type. It's an empty type. So now you see what this command has done. It has cleared this picture. Okay. So that's how we invoke. Now let's use another service which we call the ROS service type spawn. So there is a service which is ROS service type total same spawn. So this is the service. So if you want to see show so it will show us float and 30 what is inside it, theta, name and string name. So if you want to call this service, okay, so let's type let's call this service. From these services we know, let's call this service now and create another interesting thing. I'm calling this service now. I'm giving the address 3 and this is x value of my new turtle, because I'm calling the service. 3x value, which is float 32x. Another is y value, let me call it 4, and then theta, let me give it 0.3, and then name, turtle name, let me call this my turtle. So float 3 is, and this 3 is x, this 4 is y, and this is the angle, and the string name is name. So let's just run it, my new turtle. So now you can see that there are two turtles. One is on this one and the new one is this one. So angle is also there. So that's how we call the services. Okay. Now we have experienced how to use services. Now let's see how to use parameter server. First of all, let's see what is in the ROS parameter. First, let's clear the window, and then let's see what are the parameters servers available. Run ROS-Programming. So these are the parameter servers available for the this tutorial. Background BGR and ROS distro and etc. The background parameters are of the turtlesync node. These parameters change the color of the windows that are initially blue. If you want to read a value, you will use the get parameters. So for example, ROS PARAM PET dash KCK underscore B. So you will get the background value. This is blue. Here you can see it is blue. This is 255, and set a new value. You use the set parameters. Let's use ROS. So what do we have to do? To see start on which node? Okay. Now we have practiced some ROS parameters. I don't know what's the problem in it, but just for the sake of argument, let's say it works. So from now on, we have seen how to run a node, how to interact with the node by the messages, how to use topics. But now let's create our own node and create our own topics and services. So for this, first of all, close everything. ROS terminal will also kill any running node. So
ROS code.
ROS code, yeah, everything. Kill. And you can kill also by the control plus C. So we are in the home. So let's see how to create node. First of all, create some folder in source folder, which is the workspace folder of the you're running this command, chapter 2 tutorials _crc. So run this command mkdir -p. So this will create a folder. Okay, now go to the root directory of your workspace, cd _workspace, and then type in source.exe. I very frequently use this command because if you are not for the first thing, if you are having some error that the directory is not being found or something like that, just type in this one. Now you need to go to the source file, catkin src chapter 2. Okay, this is my file and this one is the file. Okay, I just anyways, these are the src, and you will in my cpp you will find two files, listener and talker. Please copy, go to that folder and copy those files. Okay, so we are supposed to create these two files, and anyways, now you have to go to the tutorial section and go to the cmakelist.txt. This cmakelist.txt. So go to this cmake, go to the catkin workspace, go to source file, go to chapter 2 tutorials and go to cmakelist.txt. Now in there okay, let's get back. Now we have created these two cpp files. Now we need to edit cmakelist.txt. So go to this folder catkin workspace, your source file, your this, and then cmakelist.txt. Here you have to add some text which is about your nodes, talker and listener. So this information is in the file I have given to you here in documents, in my flash where my C files were there, chapter 2 here. So you need to copy these information and paste in the cmakelist.txt. So please go to my C files. My C files, go to and then go to chapter 2 cmakelist.txt and copy that to cmakelist, which is Catkin workspace src and here, and paste it here. I have already pasted it, just in the down, paste it here. Save it and okay. These files include these files tells your whole package that where these files are, and this information is added dependencies, executables, and everything about the listener CPP, and tells where it is and what it does and on what it depends. So now just close it and okay, and go back to your bash window and go to the home directory, cd, you are in home, and now make your this package. Your package is complete. Catkin underscore make chapter 2. So my package is built. Catkin underscore make chapter 2 tutorial. Okay, is it done? Okay, so seems everything is fine. So now let's run this. Okay, the name is different here. So let's just run these. We have just created 2 nodes. So let's run it. The command will be, first of all, you have to use the ROS code to run the master. Clear it out and then ROS core and then new terminal. So now we are going to run this node, ROS 1 chapter 2 chapter 2 tutorial. Okay, first of all we need to add setup the bash and then so it is listening, and now we have to enter another terminal again. Now we have ROS core, ROS run, first node listener, and then talker. Do you want to see that? Okay, here it is. You need to run this command first because it hasn't included these files in the bash file. So you need to update your bash develop folder. Source devel bash setup dot bash. Now you need to run ROS run chapter two tutorials. Yes, no. So was 1 into 2. No, it's okay. Tutorial. So it is saying hello world and it is I heard hello world. Okay, so these are two nodes. This is saying talker is saying hello world and it is saying I heard hello world. This is the first node. Welcome to the ROS. I think for today's session this is enough. I was hoping to describe how to make message files and service files and launch files and some dynamic reconfiguration as well, but I think for now it is done. For today's session I think it is enough. Control plus C to stop, please. Okay. The session is now open for question answer session. So if you have any comment or anything. No? Okay.
It was a very nice presentation. A big round of applause for the presentation.
Thank you.